So in part 1 of lesson 29.1, we talked about the equation of a circle and converting between a rectangular and now polar form, and how if it's centered at 0, 0, we just use this lovely r equals down here, whatever the radius is. And if it's shifted vertically, we're using the diameter in front as the coefficient times sine. Horizontally would be diameter cosine, and again, converting it back to rectangular format for equation of a circle. Now the last part of this is talking about when we just are given instead theta equals 45. Well, if theta equals 45, any r value you have is going to have a theta value of 45, which means basically what's happening here is this looks like so, like a line. Now, in order to kind of convert this and double check, we need to go back to the fact that theta has a relationship with tangent. And if we take the tangent of theta, we're going to have to take the tangent of both sides, so tangent 45 as well. Well, tangent of 45 is 1, right? And tangent, we've talked about previously, can be rewritten as our y value over our x value. So tangent is y over x, and if we just rewrite this, multiply both sides by an x, tangent equals 1x, right? The equation of a line. This makes sense just looking at our picture, because notice the slope of our line, we're rising 1, we're running 1, we're rising 1, we're running 1. We are a line crossing through a y-intercept of 0 with a slope of 1. So that all makes sense there. So if we look down below at another example of this, theta equals 60, again, just using kind of our common sense here, theta equaling 60 means that we are constantly going to have a value for 60, right, no matter what our r value is. So again, that line format. Well, again, theta equaling 60, if we tangent both sides, tangent of 60 is the square root of 3. So we can rewrite tangent as y over x. We can rewrite tangent 60 as square root 3. And we are able then to see from here that if we multiply both sides by x, we have again a line with the slope square root 3x.